definitely not. Okay, here we go. So we're going to graph 5 problems here. We're not going to do this last one. That's sitting right here. We're going to get rid of that. And this is the basis for the beginning of our study on graphing trigonometric functions. It all stems from this. Please make sure you can do this. Please make sure you do this assignment this weekend so that when we come on Monday, you're prepared. The lesson on Monday is the most important lesson of the unit, and I'm sure you'll do fine with it. Yesterday, we talked about the amplitude and the period of a graph. Does anybody remember how we determine the amplitude of a graph? Absolute value of A. Thank you very much. Patty, on the ball. Absolute value of 3 is 3. How is it then we determine the period?
The absolute value of A, sorry, 2A divided by the absolute value of B.
Close. 2 pi divided by B. So, yep. So we're going to take 2 pi and divide it by the number in front of x. What's the number in front of x? 1. So you can see 2 pi over 1 is 2 pi. All good with that? So what I'm going to do is graph this function by identifying amplitude and period. If the amplitude is 3, I'm going to make 3 tick marks. And then on the x-axis, I'm going to mark off 2 pi. I'm going to divide it in half to get pi. What do you get if you divide pi in half? Or pi over 2. The third tick mark is always 3 times the first tick mark, so 3 pi over 2. I'll do the same thing on the other side. Okay. Where does cosine start?
Cosine starts.
1. Why'd you say 1? Okay, so he's thinking about cosine of 0. So think about the unit circle. If you're at 0 degrees or 0 radians, what's the coordinate over here? 1, 0. And is cosine the x value or the y value? X. So 1, 0. Cosine is the x value, so 1. So cosine starts up at this maximum value, whereas sine starts in the middle. Now think about that. The cosine of 0 is 1. So you get cosine of 0 is 1, and then you multiply by 3, you get 3. So it starts up here. So if I'm at the top, I'm going to end up going down. So you're going to cross over the middle. Yep. Nowhere else to go but up, all the way to the top. I'll repeat the same process on the other side. And there are so many connections here. And I'm just going to try to show you one. For those of you who are struggling, keep the unit circle kind of in your brain. I'm going to help it bring back to you right now. In the first quadrant, is cosine positive or negative? It's positive. In the second quadrant, is cosine positive or negative? It's negative. How about in the third? Negative. And in the fourth? It's positive. Notice how the graph models exactly what the values of cosine are. The graph of sine and cosine are literally the unit circle visualized in front of us. That's what makes it really cool. What's different about the first graph? Okay, it is negative, and that's going to affect the graph. The amplitude is simply 1. Please never write a positive number or a negative number. The amplitude is always positive. What's the period? 2 pi, just like we had on the previous one. It would be normal if you started to get a little bit tired of making all these tick marks. The fact is, it is important. These come back and are used often. So we're going to make sure that we get used to dividing these up. I can think of the 3 lessons in calculus where it's useful to know these. So amplitude is 1, so I'm going to mark off positive 1 and negative 1. My wife made supper last night. She put a pork butt in the crock pot. And so we did barbecue pulled pork sandwiches, like on subs. And then she made these really good red potatoes with like some garlic powder and salt and pepper. And, oh, it's just perfect. Loved it. Better pause the video for that one. I do most cooking, so. Okay. Where does sine start? Does it start max, min, or middle?
Middle.
Starts in the middle. As Gavin says, he says, you know, the y value over there is 0. So that's why it starts here. And you're absolutely right. Yes.
Can you explain why it starts at 0?
I will. Thank you for asking. So once again, what we're doing is we're looking at angles 0, pi over 2, pi, and 3 pi over 2, and 2 pi. And these all have what we call terminal points, which would be 1, 0, 0, 1. So when you are at 0 radians, sine is the y value. That's why it starts at 0. Cosine is the x value. It starts at 1. See that now? Yes, thank you. So we will eventually graph tangent. So so tangent would be y over x, wouldn't it? Which would be 0, right? But then when you get to here, tangent would be undefined. And you're like, what do you do when it's undefined? You have a vertical asymptote. Just like when you graphed 1 over x minus 2, you got vertical asymptotes, didn't you? Yeah, so, yep, curiosity is good. Asking the questions because you're tying things together. Sine's going to start where? And it's going to go? Why? So it wants to go up, but the negative creates a vertical reflection, so it's going to go down instead. And then from there, it will go. Gav, what are you looking at? All right, what's the amplitude? 4. And what's the period? 2. How do you get that?
2 pi.
2 pi divided by pi.
Yep, 2 pi divided by pi is 2. Very good. Mark off 2. 1. How did I get what? 4. And then the period is 2 pi divided by your b value. The third tick mark is always 3 times the first tick mark. So 3 over 2. Okay, I've got the structure of my graph set. Does anybody have questions about the structure of my graph? Okay, where do I start? Middle. And which direction do I go? I go up. Good. Got 2 more problems. What is the amplitude for this one? 2. Yes. So as you can see, our graphs are being represented like this. 2, so you see how it completes 1 cycle every 2 units. So that would mean in this graph, it would complete the cycle by there. because 2 is between, is less than pi, isn't it?
That's basically based on where you put your
Yes. And that will be clarified when we do this example right here. You'll see that. Okay. All right. What's the period? 6 pi. Laura, question? So I'll mark off 2 and negative 2. Six pi. Halfway's 3 pi. Half of that is 3 pi over 2. So sometimes people write 1.5 pi. That's fine, but I just think it's easier to say if you take half of 3 pi, you get 3 pi over 2. The third tick mark is 3 times the first tick mark. 9 pi over 2. Where do we start? Bottom. Cosine starts at the max or the min. In this case, because it's negative, we start at the minimum. I have nowhere to go but up. After a while, the graphs kind of start to look like each other, don't they? We're going to make sure that that is clarified as we do our last example. We're going to put 2 graphs on the same graph. And that way, we can see how they definitely differ from one another.
If I was to put this on my calculator, would it look like how we're drawing?
I'm going to put those on the calculator, and we're going to see exactly that. So, amplitude for each one. 2 and 6. Period for the top one. 2 pi. Period for the bottom one. Avery is correct, and so are many of you. She expressed it as pi over 2. She took 2 pi over 4, which simplifies to pi over 2. You good? Okay, so as I mark this out, I got to get both these graphs on one graph. So notice I have an amplitude of 2 and 6, so I can make sure I go all the way up to 6, right? So 2, 4, 6. And then, if I have a period of pi over 2 and 2 pi, I'm going to make sure I stretch all the way to 2 pi. Just had a great idea. Wait to make sure everybody has a structure, and then we'll work on graphing these. We good? Okay, I'm going to start by graphing the one that goes the full period. I'm going to start by graphing this one. I think that because it goes the full period there, it's going to be easier to sketch. So where will I start? Middle. And I go down from there, but how far down? Down to negative 2. And then back up and up. And I'm going to create that same pattern on the other side. What's that? So it's the sine graph. Because it's the sine graph, I start in the middle, and the negative creates a vertical reflection. So therefore, instead of headed up, it's headed down. Better? Okay, now let's do the next one. Where do I start? Start at 0. It's still a sine graph, right? Well, I start by going up or going down. Where do I go up to? Now hold on, folks. It completes a full cycle by pi over 2. So instead of taking this distance to complete its cycle, it completes a full cycle by the time you get to here. So that means I got to go up and down and back up by the time I get to there. So it isn't until we, every time, so it isn't until we sketch two graphs on the same axes that we really see the effect of all these transformations. And now I'm not expecting that your graph be perfect. And so Marissa asked the question, she said, come on, Gens, if we were to sketch these on our calculator, is that what we would get? And so as I turn it on, I go into y equals. You can see I've typed them in. I've made the first one bold. And then as I go to my window, you can see my x min is negative 2 pi. My max is positive 2 pi. I put a tick mark every pi over 2. My y minimum will go negative 6. My y max positive 6. A tick mark every 2. And you can see and judge for yourself whether or not we really made an accurate representation of the graph. Sometimes people look at it and they're like, well, it's just a bunch of lines and curves and it's not very accurate. I'm going to say it's about perfect. We're not just making, just wild guesses of our sketches. They're pretty much spot on. So, Mr. Trey, you can see that we didn't do that example, did we? So, I see Trey first hour as well. And so, second time he's seen this. A lot of people, I actually have a number of students that even after they take trig their junior year, they maybe take plane trig their senior year just to get a review of it. They find it helpful. So Trey just loves the teachers, so it just keeps showing up. So anyway, take out your assignment. We're going to give you a couple problems as optional.